Let's look at number 2 here. So sodium metal reacts with water to produce hydrogen gas and sodium hydroxide according to the chemical equation shown below. When 0.03 moles of Na is added to 100 grams of water, the temperature of the resulting solution rises from 25 degrees Celsius to 37.9 degrees Celsius if the specific heat of the solution is 4.18 joules per gram per Celsius. Calculate the change in heat for the reaction. Okay, so I'm going to write down the chemical equation first. 2Na(S) plus 2H2O. I think this is actually incorrectly balanced. It should be NaS plus H2O gives us NaOH plus H2. Let me just check. Oh, no, it's not. It's not. This is good. It's 2 NOH. Okay. So we have this chemical equation, and then we want the change in heat. So delta H or Q or whatnot. We want to find the enthalpy. So what we're doing here is we're going to find out our we want to find out our enthalpy of the reaction. So we know that our equation for that is Q equals MC delta T. We're solving for Q, and what we want to know is we want to know our mass and our we want to find our enthalpy change, and we're given our mass, our specific heat capacity, and our delta T. So what we want to know is we want to figure out our mass first, and this is the mass of, it's going to be the mass of our sodium in water, right? So we want to figure out how much what is the mass of sodium here. So let me just erase this and bring this. We'll come back to this equation, but we're gonna have to do some stoichiometry first. Yep. So this is Q equals MC delta T. So what we're gonna do first is we're given our moles of the solution, right? So we have 0.03 moles of Na. And what we want to do is we want to figure out the mass of our sodium here. So because we're already given our mass of our water, we want to figure out the mass of sodium, right? Because in our reaction, it's going to be the total mass of both those guys there. So we're going to have to do some stoichiometry. So we know this is moles. We want molar mass, and we want to find out our mass specifically. So let's look at periodic table and let's look at sodium here, which is 22.999 grams per mole, and our mass is simply just moles times molar mass, right? So that will give us our mass, which is 0.03 times 22.99 grams per mole. This will give us a value of 22.99, gives us a value of 0.6897 grams. And now what we can do, and we have 100 grams for water, right? So we have 100 grams for water. So what we can do now is we can actually look at both our masses here, and we can add these masses together to give us our total mass for Q equals MC delta T, and then we can solve that the solution here. So we have Q equals the mass of total C delta T. So Q equals 0.6897 plus 100 grams times the specific capacity of the solution, which is 4.18. This is going to be joules per gram degree Celsius. And finally, we have our T initial and T final, right? So it's rising from 25 to 37.9. So it's going to be, we're going to do 37.9 degrees Celsius minus 25 degrees Celsius. And we can plug this all into our calculator to get simply just Q, right? You have 100 plus 0.6897, which is 100.6897. multiplied by 4.18 multiplied by 37.99 minus 25. This will give us 5,429. And this is 5429, which is the correct answer here. So our solution matches up with theirs. 0.4 joules, or we can say, because this is in, let's look at our significant digits. We have 3 significant digits here, 3 here. We have 2 here, So we're going to have to actually do 2 significant digits. So this is going to be 5.4 times 10 to the 3 joules here. And this will give us our answer for this problem. So this is our solution for this problem, 5.3 times 10 to the 3 joules. So the solution is correct, except they didn't put in significant digits, but it's okay. Solution is correct. Good analysis. Technically, 5.4 times 10 to the 3 joules for 2 significant digits. The answer is correct.